Time for the last video of the semester for probability and statistics. And I'm doing this one on the iPad, so you'll notice it's a little bit different than the others. It's because I have some images that I wanted to share with you, and this is a much better option than trying to put them underneath the camera. Okay, so to begin with, we're going to talk about this R, which is the correlation coefficient that we talked about earlier. And so the real question is, what does the correlation coefficient, or R, tell us? And I kind of gave you a little bit of a picture about that earlier, but let's go even further into it. Maybe not further into it, but let's just kind of repeat the things that we said before. Well, we know that R can be any number between -1 and +1. But what we also know is that +1 is highly correlated. And so things that are in this area will be things that have graphs that look kind of like this, where they're growing. And the closer it looks to a line, the closer it is to +1. If it was over here in this area, then your graph would be going up, but it might have a little bit of a bounce to it as it goes up, right? So it just depends on how close you are to 1, as to how close you are to a line. Now, things over here in this area of the graph similarly are going downward in a negative way. Things kind of in this way, they have some negative to them. They have some negative to them, so notice that one tends to have a negative value, but it's much smaller negative than what's over here. It's much less like a line. And then finally, things that are close to 0 are things that don't seem to have any sort of correlation at all. So things that are just look like a random scatter shot of dots tend to be in the middle. So what I wanted you to do was look at these exercises on page 70 and try those out to see if you could make sense of what the correlation coefficient was for each one. So let's start with this one, and I want you to try it yourself. Just write down a number. It may not, who knows if it'll be the perfectly correct number or not, but I want you to come up with a number for yourself. Now, as I look at this, so hopefully you've paused and tried this. And as I look at this, what do I notice? I notice that they're going down, and I notice they're negative. So I would say this is probably something close to -1. So what might be a reasonable guess? Oh, I don't know, -0.9, 0.95, somewhere in that range. These are all probably reasonable guesses. You don't have to have the exact same number as me, but anything close to -1 is a pretty decent answer. This one, what I notice is that I have numbers jumping up and down. So notice my numbers jump up and down throughout the whole thing. So this tells me that my R should be close to 0. So if you put 0, that's fine. If you were to go compute this exactly with your with a computer, it may not be exactly 0, but it's probably something close to 0. Okay, let's look at this one. Now this one, you'll notice they're positive, so they seem to be growing up. So you'll notice that they're moving kind of in this positive way. So what does that tell me? That tells me that R is close to +1. So what might be a reasonable number? Maybe something like a positive 0.9 or 0.95 or something like that. That's pretty reasonable here. Now finally, this one we'll see is also positive. This one is also positive, but I would say it's not as close as the last problem. So I would say that the previous graph looked a lot more like a line than this one. And so this one is not as close to +1. So what number is it going to be? Well, it's if we put 0.9 for the last one, maybe 0.8 or 0.75 or something like that. 0.8, 0.7, somewhere in there. It should be close to +1, but not as close as the last problem. So this one should be a little bit smaller than the last one. Okay, hopefully that's helping you make a little bit of sense out of what we mean by R. And so that means that if you're given a correlation coefficient or given a scatter plot, you should be able to kind of tell what the correlation is for them. Okay, now let's move to this last one where I ask you, okay, so can we create our own regression line for this? And this is kind of like what I did at the beginning of the last video, where all I'm going to do is just draw a line on here. And so I'll just do something like that. That kind of looks like a line. that gets close to most of the values. I'm not sure. Maybe I could have done a better job. Let's try again. No. Okay, that I'm not sure I'm going to get much better. But if you remember, regression lines look like this, y hat. The textbook likes a plus bx. The calculator tends to be ax plus b, mx plus b. It doesn't really matter. All that matters is that you have one term, right? You have one term that's the slope, and one term that's the y-intercept. So we just need to figure out both of those. Notice the y-intercept is just this value right over here. So you look at your graph, you look at this y-axis, and that spot wherever it intersects is what we call the y-intercept. So if I look at this problem, my y-intercept, oh, it all deleted. Okay, well that was no good. So if I look at this one, a plus bx, my y-intercept, oh man, why did that's unfortunate. Now I have to try to draw it again. I'm not really happy with that. That's maybe tolerable. Okay. But if I look, what is this y-intercept? Well, I just look right here on my graph and say, what is that? Well, it looks like it's about halfway between 25 and 30, maybe a little bit above that. So I'm just going to go a equals 28. If you chose 27 or some other number, no big deal. And now then for the next part, I'm going to look at my slope, which is that number here. And so my slope, I simply draw some sort of slope triangle. So I'm going to look for some values that it seems like I can measure them. Well, that one I thought was 28. That one seems pretty consistent. So maybe I'll just draw a little triangle. So drawing triangles is the right way to kind of figure out slope. And now if I look here, it looks like, I did it again. Okay. Every time I touch it, everything goes wrong. Okay, so this was my slope triangle. And so that looked like it was 10, so somewhere around 13 here. And then this one looked like it was somewhere around 6. So notice you have to look at your numbers on your measurements. So this one started at 28 and ended up around 15. And this one started at 0 and ended up around 6. Notice this 13 is going down, so I'm going to put a negative there. So my A I had as 28, and my B I have as negative 13 over 6. If you wanted to make a decimal out of that, what is that? Negative 2.167 or something. Okay, so I'm ready to write my equation. My equation y hat equals A 28 minus 2.167x. That's a pretty reasonable equation to come up with this graph. Now again, if we were doing this, each one of us was doing this, we would have all done slightly different things. Some of you would have come up with slightly different numbers here and slightly different numbers here. Okay, let's now go to that second part where I ask for an estimate when x is equal to 12, so or x is equal to 7. And so if x is equal to 7, that means we're looking right here on the graph. So we can see right now that our estimate should be somewhere in the 12, 13 range. But what I'm going to do is I'm going to put it in my equation. 2.167 times 7. And I'm going to come up with a number right here. Let me type this in my calculator. 28 minus 2.167 times 7. And I got 12.83, which was good because that's pretty close to what I was guessing would be a reasonable estimate. So that was that one. And now for the next one, I'm going to do x is equal. Let's move over here. I'm going to move x is equal to 12, and then I'm just going to do the exact same thing. We can see that 12 is right here. We can see our guess should probably be less than 5, so around 2.5. But let's go ahead and figure it out exactly. And so we'll go 28. I guess exactly is not really the right term since what you'll notice we did was we just guessed at the number and then guessed at these two numbers and then plugged them in. But okay. Let's type it in and see what we get. And what I got was I got the number 2 out of here, or 1.996, but that's only because I rounded my 13/6. So I get 2 for that one. Now what's important is to come here, this final question says, what's the difference? Well, notice my data points, right? My data values all fall within this range. So here's all of my data values. I don't have data values over here at 12, but I do have data values surrounding the number 7. So my range of data values really runs from like 1 to 10. So that means this number, which is right here in the middle, would be interpolation. So this is an interpolation example because it's inside of my data value versus this 2, which is over here. This value is outside of my data, so this one would be extrapolation. And okay. And there we go. So, so that's the last thing I'd like you to be able to do. Just have some sort of intuitive feel. If you're given a scatter plot, can you just kind of guess what R is? Can you guess what the equation of the tangent line should be, or what the equation of the regression line can be? And can you make some sense out of these things? I think having an intuitive feel of these things are nice because it lets you know whether your calculations are making sense or not. All right. Good luck to you all, and I hope you do really well. And talk to you later.